So, as we discussed in first class about an atom, then whenever you are discussing about an atom, at that time atom is having one of the nucleus which is present or situated at the center of a nucleus, center of an atom, and then after in that atom there are different number of your orbits, and that orbit contains that orbit you can cause that as or as an orbit or as a shell. So whenever you have these orbit or your shells, at that time there is the presence of a nucleus, and whatever that nucleus is there, let me just share yesterday's slide with which we can just revise those things of your part first quickly. Yes, slide visible, eh? Each slide is visible
No, ma'am.
now. Now
हाँ मैम अभी दिखाई दे रही है.
Yes, ma'am.
see, whenever you we discussed yesterday at that time, simply or in part first we discussed that is an atom, and that atom is having the center part that is as a nucleus, and then after there is the presence of simply your electrons that can move like this in clockwise and like this in anti-clockwise manner, and also you can have another number of electrons that we can show like this. And now in today's class we would like to discuss, we will complete information regarding this your nucleus. This your about your nucleus. What does it mean? It means, as in yesterday's class, we look towards we.
नाक साफ करते.
Tania, mute yourself. Tania, mute yourself. Okay. So, where I was on the electrons are moving or electrons are revolving surrounding around your nucleus. And when you know this concept, then after we are completely dealing with in our present one topic, that is in our NMR, and that nothing but the nucleus. That one is nothing but the nucleus. And what is that nucleus? Nucleus is this one, and this nucleus is having the total number of protons and total number of neutrons, and which can be different for your different atoms. So what type of nucleus can be active, what type of nucleus can be inactive, or what type of your atoms, or you can say what type of nucleuses can give you the formation of NMR resonance spectroscopy, or you can say that is as nuclear magnetic resonance. That is as what? Nuclear. So, NMR, what does it mean? Its long form is nothing but nuclear magnetic resonance, or in another words, we can cause or we can call that is as proton magnetic resonance spectroscopy. And why we can name it as proton magnetic resonance spectroscopy, that we'll be learning in today's class, but after some time or in next 5 to 10 minutes. But before going towards that point, you must have to know first of all how NMR is produced. I mean to say, in yesterday's class, we looked towards what is mean by an atom. Then after we discussed about a nucleus, and whatever the nucleus is there, for that nucleus we have angular momentum value. And what is that angular momentum value? Angular momentum value is the value when your electrons, or when you are suppose for example, if you're discussing about the nucleus, then I mean to say about an atom, and in that atom about electron if you're discussing, then that angular momentum could be equal to under root of s into s plus 1 h upon 2 pi. But here, instead of angular momentum of our electrons, now here we are dealing with the nucleus. Yes, and for the nucleus, whatever the angular momentum is there, that angular momentum value is completely dependent or is completely. Let me just clear this slide. Are you guys clear up to this? I think you are much clear with this. Okay, let me tell you that is, and when angular momentum is here, whatever angular momentum formula I have been written, this is from quantum mechanics, as everybody knows very well, and we are not going into the much details of this angular momentum, because whenever this angular momentum because we do not means it is not expected for us in our NMR spectroscopy. Then after, whatever this angular momentum value is there, this angular moment, I'm little bit faster because all these data, all these things we discussed already in part 1. Now in part 2 means today's class, we are going to discuss s under root of s into s plus 1 upon h h into h by 2 pi. Whatever this s value is there, the s is nothing but the spin quantum number. What is that? Spin quantum number for an electron. And whereas if we put up this same, if we put up the let me try. Okay, I have to take another slide. Can I just erase this one slide, or let me just change the slide? Mm, we take a whiteboard so that you can be clear. Yes. It is right here in front of us. And now we will be discussing about the nucleus. See, nuclear magnetic resonance. What type of which one topic we have started? As everybody knows very well, NMR or NQR, or somewhere in literature data you can call that is as PMR. But very famous one name which we use in our day-to-day life, or which we use in our chemical language, that is as NMR. Hello? 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 Am I audible,
Yes,
guys?
ma'am.
Yes,
Yes,
ma'am.
Yes.
ma'am. Yes,
There.
ma'am.
That's why. That's why there was interruption. Sorry for disturbance. Let me continue with the point. That is NMR. What is that NMR? NMR means nuclear magnetic resonance. So as in yesterday's class, we learn about N what? That is, N means the nucleus, and nucleus contains number of electrons and number of protons. Right, everyone? झोपू नका हा. मी काय म्हटलं आता? न्यूक्लियस
Number
कंटेन्स
of protons and neutrons.
बरोबर आहे का मग?
मॅडम तुम्ही इलेक्ट्रॉन्स म्हणला होता.
हो, मग बरोबर आहे का?
हो मॅम.
No, ma'am.
What it should be? It should be number of protons and थांबा एक मिनिट स्लाइड ना थोडीशी झूम होती है. Number of protons and number of neutrons. Is that clear to everyone? And as we learned yesterday, that is, whatever these proton and neutrons are there for Hello? Hello? Hello?
Yes, ma'am.
Sorry for the disturbance. There is one important work from college. So can you guys wait for a minute? I have to send one file urgently. Okay? Just wait for 1 minute. Okay? Until then, you guys just revise yesterday's class. I'm asking you one question and answer me. That is, what is angular? What is that angular momentum value for your nucleus, and what is the value for your magnetic quantum number? Okay, beta? Is that clear? Hello? Is that clear, guys?
Yes, ma'am.
अरे यार. What I asked you, are you guys clear? Just be ready with the answer. So, what is the answer of my question? Yes, who can answer me? I think everybody has the answer of the question, which is about simply nucleus, and whatever that nucleus is there, that nucleus is having its spin quantum angular momentum value, and that momentum value is nothing but under root of s into s plus 1. Okay, so whatever this angular momentum value is there, that angular momentum value is nothing but for your electron, it is s into s plus 1 and h by 2 pi. If you go towards the nucleus at that time, that one nucleus is having its angular momentum value for its spinning of the protons and the neutrons, that is nothing but completely I into I plus 1 upon h by 2 pi. So you have this whenever you have this angular momentum value, and this angular momentum value is about specifically giving an information regarding the magnetic moment value, or the protons and the neutrons are there. The protons and the neutrons are there, and whatever these protons and neutrons are there, these proton neutron can have, I mean to say, nucleus can have this angular momentum value is for your nucleus, and whatever this nucleus is there, this nucleus can have the I value. Now, as I have told you in previous class, that is whatever this I value is there, that is for your nucleus, can be different, as whereas for your spin quantum number value, that was different. I mean to say, whenever you are going towards the spin quantum number value for electron, it is equals to s is equals to plus minus. But if you look towards the nucleus, collectively for a nucleus, this I value can or this I value can be represented in the form, or that could be in the what we can say, in the integer value, whole number, that can be 1, 2, etc., or you can say that that can be present in the different fractional values, that could be fractional, like plus half, minus half, plus 3 by 2, plus 5 by 2, minus 5 by 2, etc. Now you may ask me, ma'am, why it is so? For this purpose, you must have to know one thing, and or you can be explain this criteria by using one formula. Is this? Now, what is this? If we put up the value for your n, and that is equals to, n means what? N is equals to, if you have 1, then 1 by 2 will be the value, this is equals to I, huh? Wait a minute. Let me just make it okay. What is this? Oh, this n by 2 and this n by 2 is equals to, if you have, this is equals to I, and now this can be equals to, I mean to say, I is nothing but the spinning value, or that is nothing but the value for I, and that is equals to, if you put up the value of n is equals to 1, then what it will become, it can become 1 by 2. It can become 1 by 2 means I की वैल्यू क्या होगी, हाफ. बट अगर से हम I की जगह, अगर से हम I की वैल्यू में निकालनी है, और up the, it will become simply, yeah, I is equals to n upon 2, and that is equals to, n is equals to 2, so 2 by 2 is equals to 1. What does it mean? The term which I taught you, that is proved or not? Yes, it has been, it is just proved here. And now after this value, after this thing, now we are going towards the actual meaning of, here we end up with the first word of our NMR. And what is that word? That one word, that is nothing but the nuclear. Nuclear means nucleus. Okay, and that nucleus can have the proton. Why we can call that is a proton magnetic resonance, that we will be learning. But before that again, okay, let me tell you the PMR reason. See, whenever you have an atom, at that time atom is having number of protons and number of neutrons. Whenever you have this number of protons and neutrons, at that time these protons आवाज break होते हैं. Okay. Hello? Hello? Am I audible?
Yes, ma'am. Yes, ma'am.
Okay, okay. आवाज येत नव्हता का? Hello?
Yes, ma'am.